Hey everyone! In this video, we're going to learn how to solve exponential equations using logarithms. But before we can get on to solving exponential problems, we're going to have to learn one thing first, and that's called the change of base formula. And so please make sure that if you haven't already, this goes into any notes that you keep. And look at this formula up at the top right top right part of the page. So I'm going to find another way to rewrite what the log base b of a is. And I can rewrite that as just the log of a divided by the log of b. So the reason that this is called the change of base formula is because I'm now using a new base. Both of these, the log of a and the log of b, use base 10. Remember that this is called the common log, and when I have the base of 10, I don't even have to bother writing it. So I'm just writing the log of a, and then I'm writing divided by the log of b. And that is equivalent to the log base b of a. One of the reasons that this change of base formula is very helpful to us is because in our calculators, we can easily type in the log of a number without having to change the base, if we can always just rewrite this with the common log or with base 10. So we're going to work on evaluating all of these logarithmic expressions using our calculator, and we're going to rewrite them with the change of base formula. So looking at this first one, number 21, you can ignore the numbers. But basically, what we're doing is we take this number here, the 64, and you take the log of it. And then you're going to take the log of 16 and divide. Okay. It's always, you see this number here that's a little bit bigger, and it can be a little bit easier to sometimes think that number is up higher than this number 16. So the number that starts up higher is in the numerator of the fraction, if that is helpful to you. But from there, what I'm going to do is I'm going to go ahead and I'm going to open my calculator up, and I'm just going to type in the log of 64, and I'm going to divide it by the log of 16. Okay. Sometimes people forget to like close the parentheses, and that could be problematic. So remember, the calculator will automatically kind of open up that set of parentheses. So you need to close it. And when you press enter, this will come out to 1.5. So I'll write that, and that is my answer. That is equivalent to the log base 16 of 64. And just to remember what that really tells us is that if I raise 16 to the 1.5 power, that'll give me 64. Okay. Moving along with this, I'm going to do this for a couple more problems. We have here the log base 8 of 32. I can rewrite that as the log of 32 divided by the log of 8. And I'll show you typing in the calculator one more time. If you go for the log of 32 divided by the log of 8. And that comes out to 1.67 approximately. I'm rounding to the nearest hundredth here. That's typically what I'm going to ask of you, but definitely check the instructions if the instructions ever say to round to anything other than the nearest hundredth. Okay. I guess I'll do a couple more of these just as examples. I'm going to skip down actually to the bottom, and I'm going to rewrite this one. So the log base 4 of 136 would be the log of 136 divided by the log of 4. Okay. I don't feel like I need to keep showing in the calculator how to type. So if I type the log of 136 divided by the log of 4, that comes out to 3.54. Okay. And in this last one, if I type the log of 136, remember in the calculator, a fraction is the same as just typing the division symbol. So I can type the log of 1 divided by 36, close my parentheses, divided by the log of 6. That will come out to -2. So now that we know this, we can move on to the actual point of today's video, which is to solve exponential equations using logarithms. So there are 3 steps to doing this, right? And this is the reason we just learned the change of base, because we're going to be using that as we solve. And basically, we start by isolating the exponential term. So what does that mean? Well, take the part with the exponent. You see the exponent right here. The exponential term is just the base and the exponent, so 2 to the 3x. I want to isolate that or get it on a side of the equation all by itself. So I'm going to perform different operations to get that all by itself. And how that's going to start is I'm going to go ahead and divide both sides by 3 to get rid of that 3. That would leave me with 2 to the 3x is equal to 8. Now, at this point, there would be a couple different ways to solve it. One way that we are used to solving it is that you can rewrite the two sides of the equation with the same base. So I could rewrite 8 as 2 to the third power and solve it that way. But the reason I'm showing us this is so that we can learn a new method. So what I'm going to do is start with that method that we've learned before, which is rewrite with the same base. If I do that, I end up with 2 to the 3x equals 2 to the third. So I can set the exponents equal to each other and solve for x that way. And I find that x is equal to 1. So I know that that's my answer, and I'm just going to keep that in the back of my head as I solve in this new method. So in the new method, my second step isn't to rewrite with the same base, it's to rewrite in logarithmic form. So I'm taking the equation of 2 to the 3x equals 8, and I'm going to rewrite that into logarithmic form. Now, remember that writing in logarithmic form involves me knowing what a logarithm is. So a logarithm basically asks what power takes me from one number to another number. So what power takes me from 2 to 8? So the power, or the exponent, is always the answer, because that's what a logarithm is looking for. So it's really log base 2 of 8 is equal to 3x. From there, what I can do now is I can evaluate the left side of this equation. So look, the log base 2 of 8 might not be something you know in your head. It might be something you can figure out, right? Like 2 to what power gives me 8? Well, 2 to the third power. But if not, go ahead and type in your calculator the log of 8 divided by the log of 2, right? That's where this log of, or change of base, comes in handy. If I do that, I will in fact get the answer of 3. So 3 equals 3x, which is the same equation that I had here. And if I solve it, once again, I will find that x is equal to 1. So we can see here that if we write this in logarithmic form and solve, we get the same answer as if we rewrite both sides of the equation with the same base. Now, this side is probably a little more complicated, this method. The reason that we're learning it is because sometimes you won't be able to write both sides in terms of the same base, and that's where you really need to be using this formula and why we are learning it. Okay. So let's solve out another problem. So again, I have to start by isolating the exponential term. So I want to get 10 to the 3x all by itself. Okay, in order to do that, I'm going to use my inverse operations to get rid of that multiplication of 2 and the subtraction of 1. So if I go ahead and start by adding 1 to both sides, that'll get rid of the 1. And I'll be left with 2 times 10 to the 3x equals 7. Then I can go ahead and divide both sides by 2 to get rid of the 2. That leaves me with 10 to the 3x is equal to 3.5. Okay? And from here, my exponential term has been isolated, so check, done with step 1. Step 2 is to rewrite in logarithmic form. So I'm going to go ahead and come over here, and I'm going to say, okay, what power does it take me to get from 10 to 3.5? The exponent there is 3x. Okay, so the log base 10 of 3.5 equals 3x. Now here, typically you would use your change of base formula and go with the log of 3.5 divided by the log of 10. However, remember the common log is the base 10. That's actually what your calculator is calculating anyways. So all you really have to do here is type the log of 3.5 in your calculator. So let me do that. I'm just going to type the log of 3.5. And that gives me approximately 0.54. Okay. If you had typed the log of 3.5 divided by the log of 10, that would still work. It always works to use the change of base like that. It's just an unnecessary step, so you're just adding more work. But if you forget and you accidentally do that sometime, it's not going to be detrimental. Okay. But now, in order to continue solving, I'm going to have to divide both sides by 3. Okay. In my calculator, I'm going to keep that answer that was just there, 0.54, right? That was rounded, but I want all those decimals stored up because it keeps going. And I'm just going to go ahead and start by pressing division. That takes whatever answer I had from the previous problem and divides it by 3. And that will keep us from having any issues in terms of rounding because it'll give us a precise answer. And when I did that, it came out to approximately 0.18. The reason I ask you to type in your calculator like that, and the reason that's the only way to get a precise answer, is because if you round in the middle of the problem, by the time you get to the end, you've rounded multiple times, and sometimes your answer can just be a little bit off. the more times you have to round throughout the problem, the further off it would be. So it is best practice to always use the exact answer as you're moving forward, which means just keep the answer that was stored in your calculator and use that. We're going to skip ahead to this problem because it's something a little bit different and shows us one other important property of logarithms. So again, I'm going to start solving by isolating the exponential term. So I need to get rid of this -3. I'm going to go ahead and divide by -3. That leaves me with 10 to the 5x equals -100. Now that I've isolated, I'm going to go ahead and I'm going to rewrite in logarithmic form. And by doing that, that becomes log base 10 of -100 is equal to 5x. Okay. From there, okay, I have a log base 10 again. So that means I don't even have to do the change of base. I'm just going to type log of -100 into my calculator. Log of -100. Oh, look at that. What happened? It says error, non-real answer. Well, the reason that that occurs is because you can't actually take the log of a negative number. That is not a part of the logarithmic function. You can never take the log of a negative number. Okay. You also cannot take the log of 0. So basically, you always have to take logs only of positive numbers. So if this is the case and you at some point in your problem run into a situation where you have to take the log of a negative number, what that really indicates to us is that there are no real solutions. And that would just be your answer for that problem. So just to emphasize once more, you cannot take the log of a negative number. You also cannot take the log of 0. So just putting that out there too. I probably should have written you have to take a log of a positive number, but this is fine. Anyways, moving on. We're going to do maybe 1 or 2 more examples just to see if you get practice. At this point, I would suggest that you pause the video and try this on your own before I go over it, and then I'll go over it, and you can check your work. So hopefully at this point you've already done this problem. I'm going to go over it. First, I want to isolate the exponential term, so I'm going to divide by -8 to get rid of that. And that would leave me with 10 to the 3t is equal to 12. From here, I rewrite in logarithmic form. That becomes the log base 10 of 12 is equal to 3t. Once again, because it's base 10, I can just go ahead in my calculator and type the log of 12. When I do that, I end up with something that is approximately 1.08. So I round it when I write it on my paper, right? Because I'm not going to write out like 8 decimal places on my paper, but just know I'm storing that number in my calculator still. So like if I were typing here, I would be typing the log of 12 and then leaving it here. Okay, and then the next step is going to be to divide by 3 to get t by itself. And when I go back into my calculator, again, I'm using that stored answer and just saying divide that answer by 3. And it comes out to approximately 0.36. Okay, looking at this example here, this one is a little different because I have the exponent on the other side. So we can look at this. If you ever see a problem and the exponential term is on the right side, my recommendation, just because you're familiar with this, would be to rewrite this with the exponential term on the left side of the equation. That is not absolutely necessary, but it's going to make rewriting in log form a little bit easier and just a little more familiar to approach. So once I've done that, I do notice that there's a negative out in front of the exponential term, so it's not completely isolated yet. I'm going to go ahead and divide by -1 on both sides just to get rid of that negative sign. So that'll cancel and leave me with 10 to the 2x equals -125. If I then rewrite in log form, that becomes log base 10 of -125 is equal to 2x. Well, I can see right here that I'm being asked to take the log of a negative number. So you can go ahead and type that in your calculator if you want, but you aren't getting an answer out. So I know that my answer here is no real solutions. Okay, and then before this video ends, I'm going to do one more example. Let's see if I can find a good one. Like this one. So looking at this example, again, I want to start by isolating my exponential term. So that is 2 to the 3x. I'm going to have to divide by 8 to move away the 8. Also, just a reminder, good idea to pause this, try it on your own, and then double check your answer. I'm going to keep moving. Hopefully you paused it there and solved it out. Anyways, so I divided both sides by 8 in order to isolate the exponential term. That leaves me with 2 to the negative 3x is equal to 7. I don't know. I just typed that in my calculator. I know that. Anyways, so now I have isolated the exponential term. I'm done with step 1. I'm going to move on to step 2, rewrite in log form. So log base 2 of 7 equals negative 3x. Again, that comes because what log form is asking me is how did I get from 2 to 7? Well, I used that exponent of negative 3x. Now we are back to an example where I am going to use the change of base formula because I don't have base 10. So I'm going to have to rewrite this left side as the log of 7 divided by the log of 2 in order to type this out in my calculator. Okay. And I'll go ahead and type that. So log of 7 divided by the log of 2. Okay. And that comes out to about 2.81. Again, leaving that answer in my calculator, but then I'm going to go back to just rounding it the way I write it on the actual paper just to show my work before I divide both sides by negative 3 to get x by itself. And then as I type it in the calculator to get my final answer, I'm just going to divide that answer by 3 in order to stay exact. And it's actually dividing by negative 3. And that gives me an answer of negative 0.94. So hopefully at this point you feel confident with this. You've had enough practice. If you still aren't totally sure, maybe go back to the beginning of the video and then you can try pausing and doing some more practice and quizzing yourself. If you have any questions, as always, let me know. And yeah, have fun practicing solving logs.